Hello. So what we're going to work on here is an evaluation of the downside risk of your capital budget. Now I'm using my base spreadsheet as an example to get you started off. You'll need to make the underlying adjustments so that it fits your data and your design. All right. So the basic idea here is you should have created a percentage value here for yearly increases in the benefit. We're going to use this to model our potential increases, it's percentage-wise, in sales or decreases in sales based on the standard error of our sales forecast. So for example, suppose my standard error was 1.5 billion and my forecast was 57 billion. Then the percentage standard error is just going to equal 1.5 divided by 5.7, or about 2.6%. Okay? Now, NPV is a nonlinear equation, so what I would do here is enter my 2.6%. That would be one standard deviation increase or decrease. What we see here, this is my, take this back to 0. This is my base value of NPV, 22,874.50. If I go up to 2.6, an increase of 2.6%, then you'll notice that my NPV is going up to 25,372. This value here is simply the difference between the two, which becomes the standard error of NPV relative to the standard error of the forecast in terms of percentages. Okay? So you will convert your numerical standard error in terms of dollars into a percentage standard error, and then put that in for your yearly increase, and that gives you the change in NPV, gives you the standard error of the NPV. In this case, I'm just using 2,500. All right, and then we also want to check ranges. My standard error may be smaller. In this case, I'm deciding to use 1%. So the standard error of the NPV is 960, which I have down here. It's my percentage change. And then it also, my standard error, my forecast may be worse than I expect. So I could enter 5% here. It takes me to 4,800. I'm just using 4,800 as my valuation. Okay. So this is going to be the kind of the critical value that we're working with, that percentage change. Our next step is to form our NPV sheet. So what we want to do here is first, you notice that this is set equal to B9. That is set equal to my NPV. This one's set equal to my IRR, again with 0 percentage points in there, 0% change. In other words, I'm right on my forecast. I may forecast 4% increase per year, for example, but this 0% means there's no deviation associated with it. So our next step is to work with our percentage change and convert that into a standard deviation. So the mean is 0, and my standard deviation percent-wise is 2.6%. So we want to take 0 minus 3 times 2.6%, and we want to take 0 plus 3 times the standard deviation, or positive 7.8%. And that gives us our range to work with. Now what I've done here is create an equation. I have 27 points. So if I take the range, which is 15.6, and divide it by, I believe it was 6, 6, I end up with the correct number of points. So I start off here at minus 0.78% plus this value, which is 0, times the step that's going to be in my incremental steps, which is in this case 0.006. You'll have to figure that one out for yourself in terms of getting enough steps, but not too many steps. And then we go ahead and just drag that equation down to form this first column. All right, our next step, a little more complicated. What we want to do is select this area here, So remember, these are equal, those are equation signs. And then we're going to draw on down to this value, to the bottom. Come under data, and then what we want to do is create a table out of this one. So you go into what if analysis and click on data table, and your input cell is then going to be that percentage cell right up there, B9. We're going to click OK, and what it'll do is go ahead and populate everything based on these percentage changes. In other words, it will take this minus 7.8, put it here, and calculate the NPV. It will take the 7.2, put it in there, calculate NPV, IRR, etc. Alright, so that's a nice simple way to get your table completely formatted and shows the kind of the nonlinear nature of the NPV calculation. Let me just do that one more time. I'm going to go ahead and delete these guys so you can see it a little better. So again, we're going to highlight the row at the top, which includes our equations, and down as far as we want to fill. And then we're going to go into the what if analysis, data table. My target cell is going to be the B9, which is the percentage increase. And then I'm going to hit OK. And again, that's just going to go ahead and populate everything that I need. Now, in order to calculate our downside risk, we're using a function known as norm.dist. We're going to select our cell for NPV. We're only going to plot the NPV one. And then we need the mean, which is our F24. We need the standard deviation, which is our F26. And 1 means we're asking for our cumulative. And as you go across here, you'll see that we're just using the mean and new standard deviations, always referencing back to the original cell. And the same thing here. So this is, oh, I didn't want to do that. This is like average. So that value is the average rates. Okay, our next step that we might want to do is to go ahead and plot our downside risk. In this case, we want to plot, let me just go ahead and insert, and I'm going to look for, and I don't want any points in this particular one. We'll go into the design and the select data aspect of it. Cancel this thing. I always put it right where I want this thing to go. All right. So again, we're going to data select. We'll go ahead and select our downside risk associated with it. And we'll go ahead and edit our x-axis, which is going to be the percent change in sales from our nominal value. And we'll go ahead and edit this series and say this is a forecast error of 2.6%. All right, so this becomes our underlying downside risk curve. We can go ahead and add another data series to it. The series name is a forecast error 1%. And then our series values are going to be these. Okay, and then we can add one more series to it, which would be forecast error 5%, and select our 5% series. And then I'm going to move that to a new chart location. So these become my downside risk curves. We're all running through here in 0. We'd want to set this one just to straight 100%. You can see as I decrease my forecast error, my NPV is shifting towards the positive side. Our bottom curve here, as a matter of fact, I'm going to go ahead and change that. Rather than the downside risk, we'll just put straight in the NPV values. All right, and then you can read it as, on average, we're going to be around 22,874.50, and then what the probabilities are for drops in our NPV and our probabilities for increases in our NPV. So that's the basic process. Thanks a lot. Bye.